In this lecture, we are going to talk about the pressure measurement. Pressure is one of the important process parameter that is measured through instrumentation, and it helps in operating the plant safely and reliably. So let's dive into it. So what are the topics that will be covered in this particular lecture is what is pressure, why we measure pressure, what are the different technologies that are available to measure pressure, and some of the commonly used pressure instruments. So first, what is pressure? It is defined as the amount of force applied to a surface or distributed over it and measured as force per unit area. So as you can see here, this particular diagram, so at the top there is an area of 1 centimeter square, and at the bottom there is an area of 100 centimeter square, right? And the weight of the block is 100 kg. So if you see in this picture, so weight is the basically the force, right? So the pressure will be the force divided by the area. So in this case, in the first case, it will be 100 kg divided by 100 centimeter square. So 100 cancels out, so it will be 1 kg per centimeter square in this particular figure. If we invert the figure where 1 centimeter squares come at the bottom and 100 centimeter squares goes on the top, and the same 100 kg is the weight of the block, then what will be the pressure? Obviously in this case it will be 100 kg divided by 1 centimeter square equal to 100 kg per centimeter square. So this is one of the concept. I mean, uh, this is this is taught in the schools and colleges, but sometimes people mistake still does the mistake of this. So while talking about the pressure measurement, it is important to consider that pressure is basically the force divided by cross-sectional area in which the force is getting applied, right? So it is important to remember this concept. Next, why we measure pressure? First of all, obviously safety is the prime concern while we are measuring pressure. So in the process industry, there are many process vessels in which there are chemical reactions takes place, there are hazardous material gets stored, right? And over the period of the time, the pressure may increase or decrease. If the pressure increases the beyond the design pressure, right? So there is a chance of disintegrity or chance of leakage, and that may result in the hazardous leakages, and that in turn may cause fatality, environmental issues, all these things, right? So one of the major reason why we measure pressure is obviously safety. Second is process efficiency. So if there is a undesirable pressure swings in the process plant, then it may result in producing off quality product, right? And in that case, there will be financial losses, right? And third is cost saving, as a stable process results in substantial saving in comparison to an unstable process. So obviously this will increase the productivity and saves you lots of money. So other than, I mean, there are other ways by which inferred measurement can be taken about the pressure, which is rate of flow through a pipe, or liquid level in a tank, or density of the fluid. So these are for the inferred measurement of the other variables, right? So uh, by measuring the pressure, you can measure the rate of the flow, or basically you can measure the flow by measuring the differential pressure through between 2 points in the pipeline. And by measuring pressure, you can measure the level, because you know the pressure at the bottom of the tank will be equal to H rho G, right? So it will be H rho G. So if you measure the pressure and you know the density and G, that is gravitational constant, so you will get to know the H, which is the level, right? And also the density of the fluid sometimes, because if you know the pressure, if you know the H, and if rho is unknown, then you can get the rho also from the pressure measurement. So this is how the pressure measurement work, and this is why it is important. Now, this is one of the very important topic in the instrumentation. This is the, like, how we measure the pressure, right? So there is a reference, right? Whether we are measuring with absolute reference or there is a atmospheric reference. So if we measuring pressure with respect to absolute pressure, so absolute pressure means there is absolute vacuum, there is no particle or no element present there, so that is a vacuum. So if we measure the pressure with respect to absolute reference, so that pressure becomes an absolute pressure. So if this is your absolute reference where there is no molecule, nothing present, you are measuring a pressure. Suppose this is the pressure, and this particular delta will give you the absolute pressure. But normally whatever pressure we measure is with respect to the atmospheric pressure, right? So if this is your atmospheric pressure and this is your the level of the pressure, so this delta becomes your gauge pressure, right? So as you can see from this particular chart, that absolute pressure is sum of atmospheric pressure and gauge pressure, right? So this is very important to know. And another aspect is the gauge pressure, as it is measured with respect to the atmospheric reference. So atmospheric reference changes with the uh, with the height, right? With the height of that particular location from the sea level. So if it is measured at the sea level and your temperature is like 16.5 degrees centigrade, then the atmospheric reference is almost equal to 760 millimeter of Hg. But this atmospheric reference changes with the height and also the temperature. So we have to be careful while measuring the gauge pressure. So while saying about the gauge pressure, we should refer that what is our reference is, right? So that is very important. Normally all the measurements that we do are gauge pressure measurement, and only few cases, like where the pressure is very small or less than atmospheric pressure, that kind of situation, absolute pressure is used. So one of the area where absolute pressure is measured, I can say, is a flare header pressure measurement. Is sometimes it is measured uh, in the absolute pressure. Also the firebox pressure, draft pressure, they are measured in the absolute pressure uh, as a reference, right? But all the other pressure measurement are normally done with respect to the gauge pressure, right? So this is the difference, and this particular equation, always remember this. And like, this is very important, and I have seen people who uh, don't know this particular thing even after they have sufficient year of experience in the industry. So it is better to clear this concept at the very beginning. Now, these are the some common pressure instrument that we see in our daily life. It may be our tire pressure measuring device or the blood pressure measuring device. So these are the some of the common pressure measuring instrument that we see in our daily life. Again, these are the sum of the common pressure measuring instrument. So, and this can be classified into two groups. One is local measurement, another is remote. So local measurement can be a gauge, pressure gauge. So there are different type of gauge like Bourdon gauge, bellows, diaphragm seal, etc. And in the remote uh, instrument means the indication or the sensor information is available remotely, that is through a transmitter. So it is normally known as a pressure transmitter or PT. And if it is a differential pressure measurement, it is known as the DPT, and DPT is used in level and flow measurement, and also sometimes if you want to measure the differential pressure across some equipments like filter and etc., the differential pressure measurement is used. Now this is a simple data sheet of an instrument and pressure measuring instrument, and you can see there are various components that are highlighted. What is the instrument type? This is smart or hard type. What is the process connection? What is the process connection type? And there are piping data, there are process conditions, there are measuring units, whether it is diaphragm seal or not, and then what are the electronics that are used, what are the electrical area classification, what is the cable entry, what is the accessories that are used, what are the special requirement, whether the NES certification is required or not, whether ATEX certification is required or not. All these things are covered here. In our subsequent lecture, we will be discussing in much more detail about the datasheet, and also discuss in detail about the local instrument and remote instrument and how they function really. Thank you.